we need to show that the points A, B, and C are collinear. Okay, let us begin. First, let us suppose we have 3 points, point A, point B, and point C. We're also going to consider another point O, which is going to be the origin of some coordinate system. It's going to be a 3-dimensional coordinate system. Our next task will be to define the position vector of point A. All you have to do is join point O and A with the help of a directed line segment. Now that we have joined O and A with the directed line segment, that means it's a vector going from O to A. So the position vector of point A, so let the position vector of the point A be defined by OA vector. Now our next goal will be to find the value of OA vector. So here what we'll do, we'll take the coordinate of point A, so that's -2, 3, 5, and we will subtract from it the coordinates of the origin, which is simply 0, 0, 0. We'll start with the x coordinate. First we'll take the difference of the x coordinate, so that will be -2 minus 0, and multiply it with I cap to indicate that it's the component along x direction. Then we add it to the difference of the y coordinate, so that's 3 minus 0, multiplied with j cap indicating it's in the y direction, and then finally we have 5 minus 0 multiplied with k cap. So that means the position vector of the point A, that's given by -2 I cap plus 3 j cap plus 5 k cap. Then we can define the position vector of point B. So similarly we can define the position vector of point B. The OB is going to be equals to I cap plus 2 j cap plus 3 k cap, and the position vector of the point C, that's going to be given by 7 I cap plus 0 j cap minus k cap. Okay, next what we'll do, we'll try to find out the vector AB. Now finding out the vector AB, all we have to do is take the position vector of the endpoint, so that's the vector B, that's the point B, and from it subtract the position vector of the initial point, which is the point A. So we have OB vector minus OA vector. Now let's find out the value. So we have I cap plus 2 j cap plus 3 k cap, and from here we're going to subtract the vector OA. So we have negative of -2 I cap, makes it positive 2 I cap. Then we have negative of 3 j cap, so we get -3 j cap, and minus 5 k cap. Fine. So this is going to give us, so I cap plus 2 I cap, that's 3 I cap. Then we have 2 j cap minus 3 j cap, so that's going to be -1 j cap. And then we have 3 k cap minus 5 k cap, so that's going to be -2 k cap. So this is going to be our vector AB. Next what we'll do, we'll try to find out the vector BC. All we have to do is join point B and C with the vector going from B to C. Now in terms of the position vector, it's simply OC vector minus OB vector. So that means we have 7 I cap minus k cap minus OB vector, so that's I cap minus 2 j cap minus 3 k cap. That's going to be equals to 6 I cap minus 2 j cap minus 4 k cap. Fine. Also what we can do, we can take 2 as the common factor, so that means we have to multiply to 3 I cap minus j cap minus 2 k cap. However, we have already defined AB vector as 3 I cap minus j cap minus 2 k cap, which means that we can now express, so here we have expressed the vector BC equals to lambda times AB vector, where lambda is going to be some scalar with a value equals to 2. Now whenever this particular criterion is met, this only suggests that the point A, B, and C are collinear points. So here we have successfully solved our problem. So we have showed that the points ABC whose coordinates are given are collinear.